Hi all, welcome to the next lecture in image enhancement. It's the color image processing. So the color image processing. So we know that the color is a powerful descriptor which simplifies the object identification extraction from a scene. So the color image processing are the area is divided into two types. That is the full color image processing and pseudo color image processing. So in full color, the images are acquired with a full color sensor, such as a color TV camera or a color scanner. In pseudo processing, the problem is one of assigning a color to a particular monochrome intensity or a range of intensities. So the color image processing, it basically deals with the primary and the secondary colors. So we know that the primary colors are RGB, that is red, green, and blue. And by mixing these, we'll be getting the secondary colors, that the magenta, cyan, and yellow, or CMY. So another type of color image processing or the color model is the HSI model, that is the hue, saturation, and the intensity. Okay, so the brightness, okay, so intensity, or we'll call it as the brightness. The brightness embodies the achromatic notation of the intensity. And hue is nothing but the attribute associated with the dominant wavelength in a mixture of light waves. So hue represents the dominant color as perceived by an observer. So in a mixture of colors, what will be the dominant wavelength, or what will be the dominant color in that particular scene? Okay, so that will give you the hue. And saturation refers the relative purity or the amount of white light mixed with the hue. So the colors such as pink, okay, so by mixing the red and white we'll get pink, and the lavender, violet and white, when you are mixing we'll be getting lavender, are less saturated. So with the degree of saturation being inversely proportional to the amount of white light added. So in the color image processing, so the amount of red, green, and blue colors needed to form any particular color, that is called a tri-stimulus value, and are denoted by X, Y, and Z. So the color is then specified its tri-stimulus coefficient as, so X, Y, and Z as X by X plus Y plus Z, and Y X plus Y plus Y divided by X plus Y plus Z, and Z divided by X plus Y plus Z. So X plus Y plus Z is equal to 1. So that's nothing but mixing all these colors, we'll be getting the brightest or the brightest intensity, that is a white. So now we'll see about the color models. Basically, there are three color models are there. That is RGB color model, CMY color model, and the HSI color model. So we'll see one by one. The purpose of a color model is to facilitate the specification of colors in some standard way. So color model is a specification of a coordinate system and a subspace within that system where each color is represented by a single point. In terms of digital image processing, the hardware-oriented models most commonly used the practice of the RGB model. The CMY model and CMYK model, this will like black also will be included, models are used for the color printing. The HSI model that corresponds closely to the way human describe the or interpret the color. So the way in which how the human is going to interpret the color. So that means, so in the white or the red region itself, the intensity of red, how much intensity of red is there, or how much saturation of white light is added to that particular region or particular area of the image. So this all will be described by the human. So that is the HSI. So the RGB color model, so it can be represented with the help of a cube. So in this cube, we can see the three edges of the cube, three corners of the cube, that is the red, green, and the blue. So the red first value will be what, 1 or the highest intensity, and the blue, the last value will be the highest intensity, and the green, the middle value will be the highest intensity. So when mixing all these colors, we'll be getting the white. So there you'll be getting the 1, 1, 1. So that means it is having the highest intensity. So in this, you can see in this color cube also, here you will be getting, so in this corner you will be getting the more white color, in this corner you'll be getting more blue color, in this corner you'll be getting the more red color, and in this corner you'll be getting the more green color. So this RGB, so all these colors, so when you're adding to the color monitor, we'll be getting the combination of this combination of red, green, and blue color. the CMY model or CMYK model. So it is nothing but the cyan, magenta and yellow. And the secondary colors are mixed together to get the CMY model. So most devices that deposit colored pigments on paper, such as color printout and copies, require CMY data input or perform an RGB to CMY conversion. So for the printing of any kind of images, okay, for the printing purpose, so we need the CMY, because like we need the mixture of colors. So that time we need the CMY like colors, or we have to convert the RGB color models to CMY. So how to get the CMY from an RGB? So it is nothing but you have to subtract the RGB from the 1. So that is all the highest intensity. Or so CMY we can get from 1 minus R. Cyan color we can get from 1 minus red, and magenta we can get from 1 minus G, and yellow we can get from 1 minus B. So HSI color models. So creating colors in the RGB and CMY models are changing from one model to the other as a straightforward process. So the conversion of RGB to CMY or CMY to RGB is a straight process. So it's nothing but you have to subtract the particular color model from the highest intensity. So, but the HSI color model, so it is difficult to, we need to do some calculation to do the HSI color model. So, we already discussed what is hue, saturation and brightness. So, the conversion we'll see. So, the conversion of RGB to HSI. So, the hue component from an RGB model can be get from this equation. H is equal to theta if B less than or equal to G, and 360 minus theta if B greater than G. So where theta is given by cos inverse 1 by 2 R minus G plus 1 minus R minus B divided by R minus G square plus R minus B into R minus G, the whole root. Okay, so the saturation coefficient can be, saturation coefficient can get by S is equal to 1 minus 3 by R plus G plus B in the minimum of RGB. And intensity component we can get from I is equal to 1 by 3 R plus G plus B. Okay, so now the color component, this in the color component we can get in the RG sector. Okay, so this is for the BG sector and this is for the RG sector. For the RG sector, so it is the blue color can be get from I into 1 minus S. Okay, so this is from HSI to RGB. Okay, you're converting HSI to RGB, and this equation shows the conversion of RGB to HSI. So the blue color we can get from I of 1 minus S, and R we can get from I of 1 plus S cos H divided by cos 60 degree minus H, and G is equal to 3I minus R plus C. So this is for the RG sector. So for the conversion of HSI to RGB, so we need to consider about the RG sector, GB sector and BR sector. So for the GB sector, so we are having these equations for H, R, G and B, and for the BR sector, so that is we are having this equation for this set of equations to find the H, G, B and R. So the conversion of HSI to RGB, so when you are doing this, like this RGB to HSI, you will be getting the hue component, the saturation component, the intensity component like this. So when you're comparing this hue, saturation and the HSI component, the hue, saturation and the intensity component, when comparing all this, you will be getting the RGB color models. So this is all about the color image processing. So in the color image processing, so we will see basically about what is the color image processing and what are the different types of color models, and the conversion of RGB to CMY and CMY to RGB, and the conversion of HSI to RGB and RGB to HSI color models. So I hope you understood this. Thank you.